So this lecture is over stars and bars, and I'll start with the investigate activity from the book. And so the investigate activity asks about the number of ways to distribute identical Rubik's Cubes to a different number of people. And so it's worth pointing out that any two Rubik's Cubes can't be distinguished from each other. So let's look at the answer, and here I designated the two people to be, so it starts with two people, and I'm going to call them Jack and Jill. And so suppose you want to distribute 3 cubes between Jack and Jill. You can either give them all to Jack, 2 to Jack, 1 to Jill, 1 to Jack or 2 to Jill, or all of 3 to Jill. And so because there's no ordering, no way of distinguishing between Rubik's Cubes, this is the total number of answers. This would be different if you were, say, distributing 3 different balls and they have different colors. Here the issue is that you can't distinguish between one cube and the next. Part B of that problem asks about what happens if you do 4 cubes to Jack and Jill. And it turns out, as you can see, there are 5 ways to distribute 4 cubes between Jack and Jill, ranging from giving all of them to Jack to giving all of them to Jill. And you can extrapolate that if you want to distribute 5 cubes between Jack and Jill, there would be 6 ways to do it. We won't bother asking why on earth you're giving 5 Rubik's Cubes to Jack and Jill when all you need is 1. The second part of this problem of distributing Rubik's Cubes is to distribute 3 cubes to 3 people. And as you can tell, the answer gets a lot harder, because you can either give all the cubes to one person. We see there are 3 ways to do that, either 3 to Jack, 3 to Jill, or 3 to Pat. Likewise, there's only one way to distribute 1 cube to each person, so they each get 1. And otherwise, you have to give 2 cubes to one person and 1 cube to another, and there are 6 possible ways to do that distribution. And so we see there are 10 ways to distribute 3 cubes to 3 people. So the next problem is to ask about how to distribute 4 cubes to 3 people. As you can tell from the previous slide, the answer starts to get too big, so trying to just enumerate all of them and then to count them is going to be time consuming. So we're going to try a different approach now. Instead, let's suppose we gave Jack A Rubik's Cubes, Jill B Rubik's Cubes, and Pat C Rubik's Cubes. Well, the total sum of Rubik's Cubes we gave to each of them has to total 4, and each of them gets somewhere between 0 and 4 Rubik's Cubes. So we're actually counting the number of solutions to this linear equation, where the solutions have to have integer coordinates. So A, B, and C all have to be positive integers. And so one way to solve this problem is to break it down into cases. Either we give no cubes to Pat, in which case we have to distribute the cubes between Jack and Jill, and we saw before there's 5 ways to distribute 4 cubes between Jack and Jill. Likewise, we could choose to give Pat exactly 1, and then there's 3 cubes left over, and there's 4 ways to distribute that between Jack and Jill. And so we're breaking up on cases based on how many cubes we give to Pat. If we give Pat 2 cubes, then there's 2 cubes left over to give to Jack and Jill, and there's 3 ways to do that. Now, if we give 3 cubes to Pat, there's only 1 cube left over, and we have to give either to Jack or Jill, and there's 2 ways there. And finally, if we give all the cubes to Pat, Jack and Jill get none, and there's 1 way to do that distribution. And so we see that by the addition principle, the answer to the problem is the sum of the answers to each of these cases. So 5 plus 4 plus 3 plus 2 plus 1, which is 15. Finally, they ask about how to distribute 5 Rubik's Cubes to 3 people. As we saw on the previous slide, that's counting the number of solutions to this equation, only now with a 5 instead of a 4. And so we can see again, one way to solve this problem is to break it up into cases by how many you chose to give to Pat. You had to give Pat some number between 0 and 5, say some number C. Then you have to give 5 minus C, the remaining cubes, to Jack or Jill. And we've seen before that there's 5 minus C plus 1 ways to do it, ranging from giving Jack all the remaining cubes all the way to giving Jill all the remaining cubes. And so then the final answer is the sum over all these possibilities. So if we give Pat no cubes, then there's 6 ways to distribute the cubes to Jack and Jill. If we give Pat 1 cube, there's 5 ways to distribute to what's left over. If we give Pat 2 cubes, there's 4 ways to distribute the remaining cubes, and so on and so forth. We see this summation of the first 6 integers, which is 21. And we see that if you pay attention to the slides so far, these look like triangular numbers. These are binomial coefficients. And problem 2 in the investigate activity is conjecturing how many ways to distribute 7 cubes to 4 people. And the book actually proceeds to answer that by changing the problem. And the answer ends up being 10, choose 3. And the third question in the investigate activity is to try to solve one of these problems where you actually decide to add the restriction that everybody gets at least 1 cube. So it's the same type of linear equation, only now every number is at least 1. And this problem pops up a lot, and one way to solve this type of problem is to do a linear change of variables, decrease each variable by exactly 1. And whatever you do on one side of the equation, you have to do on the other. So if I subtract 3, I have to subtract 3 to the other side. And so every solution in this problem is equivalent to a solution to this problem. The idea is you're taking the one each person is guaranteed to get and throwing it away for a moment. Or you could think of it as you give 1 to each of the people first, and then the solution to your problem is the number of ways to distribute the remaining 2 to the 3 people.